Vamos a empezar la siguiente sesión.
Okay, let's start with our next session. Our next speaker will be Martin Fischer. Martin Fischer, for those in the BIM universe, he's become one of our gurus. And actually, in the world, there's only one book that that talks about integrated project delivery, and it's this one book here, and his author is Martin Fischer. He works, or actually has a background in one of the best or more prestigious programs in the world on BIM, is the CIFE group at Stanford University. Actually, you are a little bit late, so we have to recover actually these 15 minutes we had. Now I give the floor to Martin.
Gracias, Ignacy, por invitarme. Hablo un poco español.
Thank you very much, Ignacy, for inviting. I speak some Spanish, but not enough, unfortunately, to continue my presentation in Spanish, so I'm going to switch to English right now.
It's my pleasure to be here. Sorry, I missed, I'm sure, a great day yesterday, but there's lots of BIM activities around the world. I was in Dubai for the 5th BIM conference in the Middle East, and Christoph as well. Yeah, I had to stay a day longer. So Ignacy suggested the title, BIM, BAM, Boom. BIM standing for Building Information Modeling, BAM for Assembly Modeling, and Boom then into Operation. And I've interpreted it in this way, but also, as we'll see, in another way, that Boom, in terms of we have achieved something great, we have made a boom. So I work at Stanford, I'm a professor there, and I'm directing the Center for Integrated Facility Engineering, which has for almost 30 years carried out research in how to integrate the disciplines, life cycle phases on building and infrastructure and industrial projects entirely for 100% for the 30 years with industrial support. So it's from that perspective that I'm making my comments. And the main thing I want to do, give you a little bit of history. Ignacy suggested I should do that. And then also give you a crash course in our current thinking. Just to get started, in my mind, there's really two big reasons to do BIM, and it's frankly a crime. I would say almost that in 2017, not every project in the world, especially in the developed world, is done with BIM from A to Z. Because as the construction industry, we create the value for our clients by delivering buildings, that means roads, etc. as well. That's what the clients buy from us, and BIM represents the building. And why wouldn't we use the best way to represent such a building? In the future, when we get to maybe more of a service kind of relationship, there may be other things, but for now, the majority of the value is added with buildings. And the other reason is that you can now buy a computing hour in the cloud for something like $0.01, maybe it's 5 cents, it doesn't really matter, unbelievably cheap. So we have to find better ways of using the computer, and otherwise we cannot remain competitive. Maybe this is well known that BIM actually started in Barcelona. Is that, did you guys know that? Really? You're not aware of it? You have this structure here in Barcelona, I believe, right? This is, I'm pretty certain, this is the first building in the world, or structure in the world, where the dimensions for construction came directly from a 3D model on the construction site. Because the schedule was so tight, and even in 1991 or 2 when it was built, the technology existed, and they had a CATIA, Gary had a CATIA operator on site, and then the workers directly connected to the workers. So I would say that was a building information model. And at least that's the first real use of a BIM that I am aware of. So for me, my BIM journey started in 1986 as I was working on this bridge in the United States. And I was a young engineer, and I reflected as I was working how much time each day I spent looking for information, reorganizing information, checking information, trying to make sure I had the latest information. And it wasn't just me, because I was a young engineer, that had to do this. I saw everybody in the office doing it. Frankly, on some days, if I was really honest, I felt I added maybe 2 hours of my 8 hours worth of work in terms of really added value. The rest of the time I felt was wasted with information management that, frankly, most of it shouldn't have to be done. So I thought there has to be a better way. And so I went to Stanford, became a PhD student, and I believe, I don't know, we just did it because that's what we felt had to be done. We developed a BIM tool on top of AutoCAD version 9 in 1988. So you could model a structure and then you could get the information about it out, and then we called it at the time, reason about it. What the particular thing we did, we reasoned about the constructability of a building. And then you could change the design graphically and redo the analysis automatically. This was the vision we had, and I think that's still very much what we need to do. In that way, BIM gives us the opportunity to combine general knowledge with project-specific information, which becomes incredibly powerful, and it's really fun for us as academics because it requires the formalization, as we call it, of new knowledge. So that was my real beginning with BIM, working together with Kenji Ito from Shimizu in Japan. We got to work on a real project the first time in 1993, when we were asked to help that hospital project that was being renovated while it was fully occupied. We were able to use a 4D model. So for that we had to build a 3D model, of course. Even though the hardware, software was incredibly expensive, $50,000 in 1993 money. Imagine if you extrapolate that and you go to your project director and say, I need this much money to just build some kind of model. People would laugh at you today. But that's what the project manager invested in it, and actually in the first sixth of the project, we paid the money back, just from the mistakes we found. So we've realized the power of a model and the related visualization to inform a team very rapidly and allow the team to do a better job. So a few years later, we had a benchmark project in our area. It was the first time in 2004 that a client, Sutter Health, a company that builds lots of hospitals, said, if anybody bidding or anybody wanting to work on this project must work in 3D, share the 3D with all the other disciplines, and must use lean management methods. Otherwise, do not apply. So that's where then the companies realized it was actually beneficial to have people working together instead of making a model like the mechanical guy, electrical, etc., making separate models, bringing them together once a week, finding lots of clashes, having to redo a lot of the work that you had done. Okay, it was better than the old way, but it was still a lot of waste. Here was the first time they worked in what's now known as a big room. You can see it's not so big, but this is the original big room. If you have heard that term, it's quite common in the United States. So the detailers for the key trades, subcontractors, worked side by side, and they could in this way create a good design concurrently without having really any clashes. So we realized that the importance of bringing the people to work together around a shared model, and then that made people quickly realize we had to change the process. Otherwise, it was like buying a Ferrari and then buying on some dirt roads and wondering, I have this expensive car and I'm not getting there any faster. Well, you need to change how you work. So, which is they adjusted the process on this project by having much more collaboration between the design and the construction team, and this back and forth, which you see with the arrow, kind of the double-headed arrow on the upper side. And then once the designers and the builders were happy with the design, they could execute it very fast because they could fabricate from the model, deliver it just in time, and this led to a much more reliable workflow, which led to project savings. And this is what the people were really interested in. They were wondering, is this any better? And this was a medical office building. There were many of those being built at the time, so there was lots of good reference data, and this project was completed 6 months faster with a 9% lower cost. So people took note. They said, okay, this may be a good way to build. This led then to the next project that was done between 2008 and 2012, a hospital. I think this turned into the first hospital in the United States where the client got the entire scope that he wanted, on budget, not for a penny more, and 30% faster than a comparable hospital. And so this showed for us the power of what we call virtual design and construction, because we have the objectives, the targets that the project team needs to meet from the client perspective, and then also from the project team's perspective. They had to make sure that the construction was highly reliable, but that's not just the contractor's problem, that's the whole design and construction team's problem. If the designer doesn't create a good design, then you cannot have reliable construction. If the designer doesn't finish design during design, you cannot have reliable construction. And so often people tell me, well, Martin, you know, this modeling is very nice, very good, but we're in a hurry. We have to start building, so we can't finish the design. Well, this project finished 30% faster than comparable, and they finished the design during design, so that there were basically no changes during construction. So it really required bringing the people together, or the disciplines, when it really mattered, to confirm the constructability of the design and to adjust the process to take advantage of the ability of people to work together, make decisions, and supported by a very detailed BIM. On this project for the $300 million hospital in 2008, they decided to model everything that was 1 centimeter or larger. Because when they started the project, all the parties looked at each other and they said, so where have we had problems in construction before? Well, the problems were always with the things that were not in the BIM. The things that were in the BIM, we rarely have a problem in construction. So why are we silly we would be silly not to put basically everything into the BIM. So that's what they did. So this is sort of a very rapid journey that we were able to be part of together with industry, otherwise we couldn't make it happen, from over 15 or so years, to move from BIM as a technology to bring it together with the people and the process and new targets, aggressive targets, which then creates what we call virtual design and construction. So why, in my experience, is BIM so powerful? This is a case from a project in Germany, Neumarkt, by Max Bögel. It's a mixed-use building in the center of the town. And they were worried a bit about really being able to create a high-performing building. Are they going to reach all of the targets that they set themselves for this goal, for this project, which were pretty aggressive? So, they realized as they were looking at how the project was going that better collaboration could improve the project. That's true almost everywhere in the world I've had the pleasure to work. And then when you look a little deeper, you realize that collaboration is, in part at least, not as good because the project information is a mess. We've talked about that before. Everybody has their own list, everybody's in a hurry, and then we spend time comparing lists and what have you. And then you realize the project information is a mess because the processes, the workflows haven't really been defined well or actually not as good as they should be. So then where should you start improving? You could say, well, start at the root cause, fix the processes. And in some cases that works well, but I found it's really difficult for the people to imagine new processes without having experienced something different. So you could start improving collaboration, because that's what you in the end want to improve. That's also difficult to do, because why should people all of a sudden work together better, trust each other more? At least I haven't seen that happen in almost, I cannot imagine it. Cannot think of a culture or project where this was the case. So I have found that starting with the information, starting with visualization is a great way of starting to have people work together, start to trust each other, start to solve problems together instead of pointing fingers, and then eventually they realize that they can they need to change the processes, but then they're able to do it. So in this project, they started to create shared visualizations to understand, for example, how the daylighting, different options that affected the daylighting, how they would kind of fabricate the project. Through that, they started to work together more, which then allowed them to create new workflows, new processes that leveraged these tools and started to measure. And with that, they saw where they needed to improve. And in the end, they were very proud of the high-performing building that they had delivered. So they were able to create a very high-performing shopping mixed-use project by having gone through this process. So what you see here was mostly the power of visualization to bring the project team together. Of course, there's more to BIM. They also then realized that they can leverage the information that was in these models to, for example, connect with cash flow. And they also then had the idea for another project that once you have a computer representation of your building, you can start to automate it. And we saw some examples earlier already. So they created these scripts to almost automatically create, for example, a parking garage. So the first sort of BIM, BAM, boom in terms of doing more with BIM, understanding boom in that way, is that we have these three types. We have the power of the visualization, then we have the power of information integration, and we have the power of automation. And I think on any project today, you should have a strategy. Which decisions, which tasks you're going to support with a visual BIM, with an information connected BIM, or with automation. And so this, as you saw, this BIM is an essential part of virtual design and construction, together with adjusted processes, bringing the teams together. We call it integrated concurrent engineering in support of project and client objectives. So we had lots of these anecdotes from projects, these examples, and we were asked by Wiley to write a book on initially integrated project delivery. We changed it to call it integrating project delivery, to highlight the need for everybody to work on integration. That it wasn't just a thing you could buy, you had to work on it. So we wanted to highlight the active part. And it brings together, the book brings together many experiences from practitioners that were collected by the two authors that work at DPR, a leading construction company in our area, and Howard Ashcraft, who is one of the leading lawyers in relational contracts, not contracts that keep people apart, but contracts that bring people together, and then us at Stanford in terms of the research we've been able to do. And we think this describes the book, thanks for showing it, Ignacy, how we think projects should be done. Well, we've had 50 years of project management approaches that largely are divide and conquer approaches. And you know what happens when you just divide and conquer, you sometimes lose perspective of the whole. And at the end, the project has to function as a whole. So this was the idea we had when we wrote the book, that we need something to counteract the divide and conquer we have to do, because we have to assign work every day. So in the book, to make it quickly accessible, we sort of struggled for a long time, actually, trying to have an overarching story framework for the book. So we were not happy with publishing a bunch of war stories, as interesting as they might have been from projects. And one day it occurred to us, we said we should ask the question, why? Like, why would you do integrated project delivery? And we said, well, you want to create a high-performing building, right? I mean, do we want to create a low-performing building? Probably not. So we want a high-performing building, so we said, okay, then we need a strategy that makes a building high-performing. What would that be? What would be the best strategy we could have about a building that makes it high-performing? And the best we could think of is, as a building, we create a building where the systems work together. We call it integrated building systems, where there are synergies between the mechanical, electrical, structural, and so on systems. And we said, okay, how do we get one of those? Well, for that, we better integrate the processes, the workflows that create this building, because otherwise it would be crazy to think that an architect working by himself and a structural engineer working by herself, totally separately, would miraculously end up with a design where the systems support each other. How do we get those integrated processes? Well, we better bring the organization together. How do we make that work? Well, we better bring the information that the organization uses together so that the information is working for the organization, not the organization for the information. So as we looked at this really emerged like this in about 15 minutes. We were surprised. We said, wow, we were working on a book on integrated project delivery. Integrated shows up over and over again. That had really just happened. So if integrated is such a powerful word and strategy, then why is it, and every project we visit, they say we are working on a high-performing building, whether that's low cost, whether that's fast schedule, whether environmentally high standard, what have you. Everybody claims they're working on a high-performing building. Then why is it that not a single project in the world, to our knowledge, uses this strategy? At least I haven't seen a building that is created with all of these aspects integrated. If you have, then fantastic. Then you should write the next book. So we were frankly puzzled by that, but also excited about the potential. So we realized we had to not only have this strategy, but we also had to have methods that allowed people, teams, project teams to work. So we had to define what does measurable value mean, what does high performance mean, and for that we could really leverage integrated information through simulating, visualizing the performance. And then we needed methods that allowed the team to do the right thing at the right time, do collaboration, and finally a way of bringing the whole team together, tying it all together through integrated form of agreement, a team charter. There's a number of ways. So this is sort of the second BIM BAM boom is from BIM to VDC to IPD. Because you have IPD, right, represented here, and if you look carefully on top, the methods, they are all the methods in virtual design and construction, the definition of the objectives, the collaboration of the people, and then the revised, better managed processes and the information on the basis, the simulation visualization on the basis of BIM. So hopefully this allows you to connect these acronyms a bit more. So I think I should just jump through this section fairly quickly. I was maybe a little aggressive in what I could cover here in a few minutes. Yeah, I will just jump through this. Never mind. I'm happy to talk to you afterwards. Just to wrap up, what really guides the work we do at Stanford is these two statements. One is the business perspective. The automated execution of process changes everything, which was actually a statement made in 1961 by Alan Perlis, a computer scientist from Georgia Tech. And the other one a little bit longer, so sorry, there's a bit of text on this slide. The scientific perspective, stated by Donald Knuth, a Stanford computer scientist in 1974. He says, science is knowledge which we understand so well that we can teach it to a computer. And if we don't fully understand something, it is an art to deal with it. Since the notion of an algorithm or a computer program provides us with an extremely useful test for the depth of our knowledge about any given subject, the process of going from an art to a science means that we learn how to automate something. And this is what I have found so fascinating in the last 30 years working with companies, trying to automate things that so far have been an art. And trying to do that really establishes the boundary of knowledge that we have. And there's still going to be, for many, many years, a lot of things that are an art in terms of engineering buildings, but many more things we can make more scientific, and then we can automate them, and then we can apply them more widely and more consistently and more rapidly. And I think this is really the task we have in the next few years in collaborating between academia and companies. So just want to highlight one project that's going on at the moment. Well, this part is done and we're extending it. You can say, yeah, BIM is very nice. It works for existing buildings. I mean, it works for new buildings. What about existing buildings? And it's still very cumbersome today you can make a laser scan now very rapidly. and then you have an image of what is where that you can look at it, you can recognize it, and you can go in and measure it. But you don't yet have a BIM that gives you actionable information. So together with a computer vision professor, Silvio Savarese, we developed a method to go automatically from a laser scan to a set of rooms. The computer automatically recognizes these rooms and then automatically recognizes in each room what is there. So that you can go automatically from a laser scan to a simple BIM where you, for example, it will tell you you have so many chairs on this floor. Or you might want to know some more useful things, but you can get wall area, etc., etc. All of this automatically from a laser scan using computer visualization, pattern recognition, machine learning methods. And so then you can quite quickly change an existing building, try out different things, for example, taking down a wall, which would be a bit time consuming, but here it's just a click, and then you're done. So all of these methods, I think, are really, really critical for us to employ very, very soon, as I already said at the beginning, because, as you know, this is really just the beginning of more and more technologies and opportunities from it. I mean, you all hear every day about opportunities from mobile, from cloud-based computing, from parallelizing processes, from location measurement methods, machine learning, robotics, additive manufacturing, Internet of Things, virtual environments, collaboration, lean management. And if you think about it, you know, these are all in the newspaper every week, every day sometimes, and this combination, any one of those will have a big impact. It's really the combination of these developments that create huge opportunities, but we cannot harness them if we don't have a formal representation of a building like a BIM. So my vision for the future of the industry is that every work hour builds the right product safely and productively. And this is pretty challenging, but we have BIM to represent the product, we have BAM to represent the building, the assembly, and then we have BOOM in terms of the operation to have the right building, right for the user, right for the environment, etc. So to close, I hope I've shown you that we have now a very different mud for our industry, and we need to learn not only to promote people based on the mud on the boots from being outside in the field, but also from the digital mud, because I like very much Napoleon's statement, who said, "I have made all my generals out of mud." And a bunch of people with digital mud on their boots and real mud on their boots are building right now the Gigafactory. That's the picture on the right in Sparks, Nevada. It's a massive production facility for Tesla, for the Model 3 and for the batteries. And they built they designed and built 350,000 square meters of factory in 10 months, from first call to the designer to finish off to the factory being ready for the installation of the tools. And without BIM, I don't think that would have happened. So thank you for your attention, and I wish you a good rest of the conference.